Here we want to find the limit of x to the a dividing by e to the x as x approaches infinity, and 8 is just a positive number and 8 is finite. So 8 is just a positive number. And so let y be the limit of x to the a over e to the x as x approaches infinity. Now if a were a positive integer, then we just apply L'Hopital's rule n times, and that will give us the limit. But here a is not necessarily an integer, a is just a positive number. Take the natural log of both sides, we get ln of y is equal to ln of this limit expression. This is the natural log of the limit, which is the same as the limit of the natural log of this function. So we have the limit of the natural log of x to the a dividing by e to the x. Natural log of x to the a dividing by e to the x is the natural log of x to the a minus the natural log of e to the x. This is the same as a times the natural log of x, and then the natural log of e to the x. This is x times ln of e. And recall that ln of e is 1. The natural log of e is 1, so we just get x. And now let's rewrite the expression a times ln of x minus x as x times a times ln of x dividing by x minus 1. And now we have limit of a product, which is product of limits. So here we have the limit of x times the limit of this expression. Now let's find the limit of the of a times ln of x over x, because we know this will go to infinity, limit of x, and so this part will be infinity. Now let's find the limit of this of a times ln x over x. 8 is a constant, so we can write this as a times the limit of ln of x dividing by x. And as x approaches infinity, ln of x approaches infinity, and then x approaches infinity. So we get infinity over infinity, and so we can apply L'Hopital's rule. So here we get infinity over infinity, and so now we apply L'Hopital's rule. And so the derivative of ln of x is 1 over x. Derivative of x is 1. As x approaches infinity, 1 over x approaches 0, so we get 0 divided by 1, which is 0. And then a times 0 is 0. And so the limit of a times ln x dividing by x is equal to 0 as x approaches infinity. And so we get 0 for this, 0 minus 1, and then the limit of negative 1 is just negative 1. And so we have infinity times negative 1, which is negative infinity. And so now we have ln, the natural log of y is equal to negative infinity. But y is what we're looking for. Recall that the definition of exponential function is as follows. The natural log of y is equal to x if and only if y is equal to e to the x. Here we have the natural log of y is equal to negative infinity, and therefore by the definition of exponential function, y is equal to e to the negative infinity, which is 0. Originally we call y is the limit of x to the a divided by e to the x, and therefore the limit of x to the a over x as x approaches infinity is equal to 0.